Dear students, so when we talk about coordination chemistry, we have to think Werner, Nobel Prize winner in 1913, roughly 100 years back, 107 years back, he has got Nobel Prize for his research over coordination compounds, and he has proposed so many ideas and all are found to be correct now. Now we are going to see Werner's theory. And before we actually enter into Werner's theory, we should know something about the complex that we have discussed in the introduction. COCl3 6NS3. Sometimes COCl3 5NS3. COCl3 4NS3. Again COCl3 4NS3. 4 compounds I have given. Color I have given earlier. VGP, very popular name, VG Pandidas. VGP yellow. VGP Golden Beach. VGP yellow. This compound is yellow in color. This is purple. These two same molecular formula. They exist as cis-trans isomerism, therefore violet and green. Here, in solution with silver nitrate solution, if it is treated with, if 1 mole is treated with 1 mole of silver nitrate, you will be getting 1 mole of this compound is treated with excess of silver nitrate solution, you will be getting 3 moles of silver chloride precipitate. It is taken excess. This is 1 mole. If 1 mole of this compound is taken, you will be getting just 2 moles of silver chloride. If these two, of course, these two are having same molecular formula, cis-trans isomers, they give only 1 silver chloride precipitate. Why? How? The explanation we are getting from Werner's theory. Structure wise, let me just give you a clue before I go into coordination compound Werner theory. These 3 chloride ions are present outside the coordination sphere. They get ionized to give 3 chloride ions. 1 mole is furnishing 3 chloride ions, therefore 3 AgCl. Here we have only 5 ammonia. Remaining 1 more chlorine will be going into the coordination sphere, inside the sphere. Only 2 chloride ions will be present outside the sphere, therefore 2 Cl minus ion per mole, therefore 2 AgCl. Both these compounds, only 4 ammonia we have within the coordination sphere, but coordination number cobalt 6. 2 more chlorine will enter into the coordination sphere, only 1 will be outside the sphere, therefore 1 Cl minus, therefore 1 AgCl. The understanding you will be getting little bit later. Alright. So COCl3 6NS3, COCl3 5NS3, COCl3 both 4NS3. Of course isomers, therefore different color. Violet color, green color, purple color, yellow color. The yellow colored compound gives 3 AgCl. Purple colored compound gives 2 AgCl. Violet as well as green colored compound, this compound gives 1 AgCl. Reason, all of them contain 3 chlorine atom. The reason I have given here. That's what we are going to see in coordination compounds. So let us go into Werner's theory. May I rub this? We will be getting this understanding a little bit later. What is it? According to Werner, elements exhibit 2 types of valencies. There are 2 types of valencies. 2 types of valencies for elements. Elements here, valence I can say. 2 types of valences. Elements, I can represent element instead of element, I can also say metal, because mostly metals. Very rarely some other non-metal. Therefore, in general, elements possess 2 types of valences. Primary valence. Primary valence. What is primary valence? Primary valence is nothing but oxidation state. Cobalt 3 plus oxidation state. chromium 3 plus oxidation state, iron may be 2 plus or 3 plus, silver plus, zinc 2 plus, copper 2 plus. So, metal, the oxidation state is said to be the primary valency of the metal. All these metals are involved in coordination complex. Therefore, I have mentioned those metals. This is said to be the primary valency. So, primary valency of an element, usually metal, corresponds to oxidation state. Secondary valency. Secondary valence. It corresponds to, we call it as coordination number. Now only I am introducing the term coordination number. Coordination number. Oxidation state already you know. I need not say anything. But what is coordination number? Let me give an example of a compound. CO NS3 6 times Cl3. We are given this compound. It is found to be yellow in color, we said. Here cobalt is in +3 oxidation state. It is primary valency. It is primary valency. Ammonia neutral molecule 0. We have 3 chloride ions, 3 Cl minus. So these 3 Cl minus ions, 3 negative ions, nullify the charge on cobalt and therefore the molecule is found to be neutral. CO NS3 6 times Cl3. It is 3 plus, it is 0, it is 3 minus. So total charge becomes 0. If I write say tetramine, this is yet another complex. It is yet another complex. Here the charge on copper +2 primary valency. Primary valence. Ammonia 0. 2 minus secondary valence. So primary valency is oxidation number. It is satisfied by negative ions. Secondary, it is satisfied by negative ions. Satisfied by negative ions. Secondary valency is said to be coordination number. 4 is the coordination number for copper. 6 is the coordination number for cobalt. If I write Ag diamine silver 1 chloride. It is a complex. I said charge on silver +1. We know the charge on chloride ion -1. So primary valency is satisfied by negative ions. Primary valency is satisfied by negative ions. Oxidation number. Secondary valency is coordination number. What is secondary valency? 2. 2 is the secondary valency. 2 ammonia, 2 is the secondary valency for some. 6 ammonia, 6 is the secondary valency for cobalt. 4 ammonia, 4 is the secondary valency for copper. But primary valency 3 plus, primary valency 2 plus, primary valency +1. Primary valency +1, primary valency Cu2 plus, primary valency cobalt 3 plus. So primary valence corresponds to oxidation state. Secondary valence corresponds to coordination number. Here coordination number 6, here coordination number 4, here coordination number 2. Alright. So in the first point we have seen about primary valence and secondary valence. Primary valence is oxidation number, secondary valence is coordination number. In this complex CO NS3 6 times Cl3, or in the way we used to write CO Cl3 NS 6 NS3. This is the way in which Werner wrote at that time. This is the recent development. It is not the way in which Werner has given. Alright. So this is a new concept. This is older one. Primary valency for cobalt is +3. It is satisfied by this one. Secondary valency, coordination number. So 6 is the coordination number for cobalt. 3 is the coordination number for cobalt. That is about primary valency and secondary valency. Now, primary valency may be positive or 0. Primary valency of a metal atom or ion, primary valence may be positive, usually positive, mostly positive, or sometimes 0. Maybe positive or 0. Always satisfied by negative ions, or if it is 0, it may need not be satisfied by negative ions. Primary valency satisfied by negative ions. Primary valency positive means plus 2 means 2 negative ions. 3 plus means 3 negative charges we should have. So always satisfied by negative ions. If it is 0, it need not be satisfied by negative ions. For example, same example what we have given earlier, COCl3 6NS3. Here oxidation state primary valency for cobalt is plus 3, cobalt plus 3. It is satisfied by 3 chloride ions, negative ions. So primary valency may be positive and it is satisfied by negative ions. Alright. Then third point, secondary valency may be negative. Secondary valency may be satisfied by negative ions, neutral molecules, very rarely positive ions, or the combination of all. So secondary valency may be satisfied by negative ions, neutral molecules, or positive ions very rarely. It is rarely, or combination of all the ions. Combination of all, that is, it may have negative ion, neutral molecule, or positive ion. For example, if I write COCl3 6NS3 or 5NS3, 6NS3 means primary valence satisfied by negative ion. Secondary valency happens to be 6. For cobalt, secondary valency is 6. Here it is satisfied by 6 ammonia. Here 5 ammonia and 1 chlorine. CO, NS3 5 times, Cl, Cl2. Likewise, only later on we will be saying. That means satisfied by 5 neutral molecules and 1 negative ion. So, combination. So, in this particular compound, secondary valence is satisfied by 5 ammonia and 1 Cl minus. Secondary valency may be satisfied by neutral molecules or negative ions or both. Very rarely positive ions are also coming in, and that we need not bother now. Alright. Then there are 2 spheres around a metal ion. So there are 2 spheres of attraction around the central metal ion. Usually we say metal ion, very rarely some other element. So there are 2 spheres of attraction around a metal atom or ion. So 2 spheres of attraction. Around the metal atom or ion. Earlier we started with element. The element is usually metal. Very rarely we get some other metal, some other element. Therefore, we mentioned metal. There are 2 spheres of attraction around the metal, around these metals. If it happens to be the central metal ion of the complex, there are 2 spheres of attraction around the metal atom or ion. Around the metal atom or ion, there are 2 spheres. Inner sphere is said to be coordination sphere. There is a metal atom inside, maybe cobalt. Inner sphere, which is having closeness over central metal atom. Inner sphere is said to be coordination sphere. It is coordination sphere. and it is firmly attached with the central metal ion. It is firmly attached to the central metal ion. Firmly attached. Therefore, we say non-ionizable. Non-ionizable. So, this ammonia, 6 ammonia, here 5 ammonia and 1 chlorine, they form coordination sphere, inner sphere. Inner sphere. So, with this, so you just refer in the book, cobalt they have drawn, cobalt, central metal. Around that there are 6 metal ions they have drawn. Of course, equally distanced they have drawn. Likewise, 6 ammonia will be available. So here 1, 2, 3, 4. Let me write 4, 3, 4, 5, 6. So usually octagonal shape. If I draw cobalt, the shape will go like this: ammonia, 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 ammonia. Likewise it comes. So if I draw a circle, it should form like this: cobalt, 4 ammonia, 1, 2, 3, 4, 5 and 6. Single circle. Inner circle. Alright? Inner sphere. Bonded. 1, 2, 3, 4. It is firmly bonded. 1, 2, 3, 4, 5, 6. Firmly bonded. It can be like this approximately. An int and a straight line, vertical line. If you draw like this, it forms inner sphere. Coordination sphere, firmly attached, non-ionizable. I used all these words. There are 2 spheres of attraction. Now we have given with the first one only. First one, inner sphere, called coordination sphere. It is firmly attached and it is non-ionizable. Once the cobalt is bonded with 6 ammonia, it is firmly attached within the sphere. It will not get ionized. And only the 3 chloride ions will get ionized outside the sphere. At the time of Werner, he didn't use this concept and therefore I didn't write. If I go in for this one, CO, 5NS3, Cl. Inner sphere. Secondary valence may be satisfied by negative ions, neutral molecules or positive ions, negative ions or neutral molecules together. Combination of all. So both these things. So it forms 5 ammonia molecules and 1 chloride ion form inner sphere. It is non-ionizable. It is within the coordination sphere. Alright. So that's what Werner mentioned. And the outer sphere, only in the outer sphere, we have 3 chloride ions, and which is ionizable. Those 5 chloride ions which are present outside the coordination sphere are ionizable. They are loosely attached with the central metal ion. Here 1 chloride I can mention. Here 1 chloride ion, here 1 chloride ion. They are weakly attached. So, there are 2 spheres of attraction around the metal atom or ion. One is closer to the central metal atom or ion. It is said to be inner sphere, coordination sphere, firmly attached and non-ionizable. Another one, outer sphere. Those chloride ions are attached outer part and they are loosely held to the central metal ion, and therefore they are ionizable. They can be separated into ions. In solution, they get ionized. Alright? So, one is this one. Second one is outer sphere. Outer sphere. Weakly bonded. Ionizable. Alright? Those who are in the outer sphere, they are not tightly held. loosely bonded or weakly bonded, whatever it may be, they can be separated into ions under suitable solvents. Ionizable with suitable solvent. Ionizable in presence of suitable solvent. All right. So that is about ionizable valency and non-ionizable valence are two spheres, inner sphere and outer sphere. Inner sphere comprising of the ligands which are not ionizable, and outer sphere not tightly held, ionizable. Then a last point. Primary valence are non-directional. Those who are here, it is primary valence, secondary valence. Primary valence are not non-directional, whereas secondary valence is directional. For example, here 6 ligands which are attached. I said 6. They are directional. They are occupying specific position. We say octahedral. If 6 ligands are present, they are octahedral. 4 if present, square planar or tetrahedral. Square planar. If 2 are present, it is linear. So primary valence is ionizable and it is not having any direction. It is non-directional. Primary valency is present outside the sphere, outer sphere. It is ionizable and it is non-directional. With suitable solvent, it will go into ions, whereas primary valency is attached firmly and non-ionizable and it is directional. It is directional. Non-directional. If only 2 are present in the inner sphere, linear. Silver. With silver, only 2 cyanide ions are present. It is linear in shape. Suppose with copper, we have 4 ammonia ligands. It may be square planar or tetrahedral. That we have to study. We will be seeing a little bit later. If we have 6 ligands around the cobalt, it is octahedral. So 2 means linear, 4 means square planar, 6 means octahedral. Only inner sphere decides the direction. Outer sphere non-directional. Primary valency non-directional, secondary valency directional. All right. For example, if we go in for COCl3, 6NS3, if we get this type of a coordination compound, it will have 6 ammonia ligands. Secondary valency is satisfied by 6 ammonia ligands. Secondary valency is satisfied by 6 ammonia ligands. If I write COCl3, 5NS3, 6 ammonia ligands and 1 Cl minus ligand. Secondary valency is satisfied by the combination of 5 ammonia neutral molecule and 1 negatively charged ion. Suppose if it is COCl3, 4NS3, 4 ammonia neutral molecule and 2 chloride ions satisfy secondary valency. In this molecule, secondary valency is satisfied by 6 ammonia. In this molecule, secondary valency is satisfied by 5 ammonia. In this molecule, secondary valency is satisfied by 4 ammonia and 2 chloride. 5 ammonia and 1 chloride ion, 4 ammonia and 2 chloride ion. We have also mentioned same molecule of ammonia but different color. Do you remember? 4 ammonia and 2 chloride ion. These two are Vg. I mentioned like this: violet, green, P, purple, and then yellow. VGP and yellow. Secondary valency for yellow colored this complex satisfied by 6 ammonia neutral molecules, ligands. Purple color, 5 ammonia neutral molecule and 1 chloride ion. Green and violet colored compounds. For these compounds, secondary valencies are satisfied by 4 ammonia molecules and 2 chloride ions. We call them as ligands and that name is not mentioned now. And then primary valency. Primary valency. For this, it is 3 plus. Naturally, 3 chloride ions satisfy primary valency. 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 But number of ions available number of ions available, free ions. Since only 6 ammonia is going into the inner sphere, all the 3 chloride ions are outside the coordination sphere and therefore 3 ions are available. Suppose if it is CCl3 5NH3, only 5 ammonia molecules, another one happens to be chloride ion, therefore only 2 chloride ions are available out of the coordination sphere, therefore 2 chloride ions. In these two cases, only 4 ammonia molecules, neutral molecules are present. 1, 2, 3, 4, 5. I have to strike off 1. That also becomes Cl. So 2 Cl minus ions and 4 ammonia. They form inner sphere. Only 1 chloride ion will go to the outer sphere. So only 1 chloride ion will go to the outer sphere. So ionizable valence, secondary valence happens to be only Cl minus. Ionizable valence. Ionizable is only this one. So 1 chloride ion is available, 2 chloride ion is available, 3 chloride ions are available for 1 molecule. For 1 molecule, 3 chloride ions. For 1 molecule, 2 chloride ions. For 1 molecule, 1 chloride ion in both these cases. Therefore, the silver nitrate solution, when 1 mole of this solution is allowed to react with silver nitrate, you will be getting 3 silver chloride precipitate here, 2 silver chloride precipitate here, and 1 silver chloride precipitate here. Hope you understood. Even though I have written like this, when I speak, you might have understood very clearly. Let me rub and write once again so that you may be understanding well. All right. We have taken a compound COCl3 6NH3, COCl3 5NH3, COCl3 4NH3, another molecule COCl3 4NH3. Here, what about the secondary valency? Secondary valency may be satisfied by neutral molecules, negative ions, very rarely positive ions, combination of all. Here, secondary valency is satisfied by 6 ammonia. Here, 5 ammonia and 1 Cl minus combination of neutral molecule and 1 chloride ion. Here, 4 NH3 and 1 chloride ion. Here also 4 NH3 and 1 chloride ion. How? That also I have explained using the diagram. So just once again, let me draw the same diagram. Cobalt, inner sphere, how many ammonia? How many ammonia? 6 ammonia. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So, and outside the sphere, 3 chloride ions are present, Cl minus, Cl minus, Cl minus. So, how many ions? Ionizable valency means it is 3 Cl minus ions. Secondary valence, non-ionizable. Primary valency, ionizable. So, ionizable, outer sphere. Secondary valence, inner sphere. Non-ionizable. All those things. Secondary valency, inner sphere, non-ionizable, firmly attached, all those things. Here, ionizable, outer sphere, primary valence, like that. All right. Suppose if it is only 5 ammonia, if it is 1 less, 1 chloride ion comes over here. Therefore, only 2 chloride ions available here. 5 plus 1, 1, 2, 3, 4, 5 plus 1. In the next case, only 4 ammonia. 1 more chloride ion comes here. Therefore, only outside the sphere. That's what I have written. It is found to be violet, green, purple and yellow. In with silver nitrate solution, when we allow silver nitrate to react, what is happening? 1 mole produces 3 moles of silver chloride, 2 moles of silver chloride and 1 mole of silver chloride. That's what we have seen. And questions based upon this may be asked in larger. So these are all the postulates of Werner theory. And the important demerit or drawback of Werner theory is that it does not explain the color and magnetic moment of the coordination compound. These are the two drawbacks or what do we say, limitations of Werner theory. Color of the complexes. Why do we get these type of colors? We say violet, green, purple and yellow. How? Why? And magnetic properties are also not explained by Werner theory. These are the two drawbacks of Werner theory. All right. Thank you.